Hi everyone. Today is day 10 of our 30 days 30 machine learning problems challenge. So let's start with it and see what it is. Yeah. So it says that the problem is a recommender system using collaborative filtering on user item ratings metrics. I don't know what it is, but let's do the same thing that we do every day. Ask chat GPT. So hey, it is day 10 and here is the problem title. Okay, let me see what type of okay, yeah. If after finishing today's problem, I guess we will complete 33%. I'm really happy that I'm able to stick to the challenge. Hmm. Let it finish first and then we will go. Okay. So it says that for data 10, we are building a recommender system. Okay. It is going to show us the recommendations using collaborative filtering. Okay. I don't know what that is. On a user items ratings matrix. So it is going to be some sort of ratings matrix. Here's how we can approach it step by step. So it okay, good that it defines what collaborative filtering is. Collaborative filtering is a technique used to make recommendations by relying on the past interactions of user and items. Okay. So we are going to rely on the past interaction of a user and the items like the rating, purchase, clicks, etc. It assumes that if users A and B have similar tastes, then user A will prefer items that user B likes. True, like what happens between our friend circle, right? So if user A and user B have similar taste, then if we are recommend what user A will prefer, user B higher chances are that user B is going to like it, and vice versa. So this is what collaborative filtering is. Okay. Uh, so there are two types of collaborative filtering: user-based collaborative filtering, and second is item-based collaborative filtering. Recommends items to a user based on recommend items to a user based on items that similar user like. Okay, based on the similar users like it, we are going to recommend the items on the basis of that. Now, item based collaborative filtering is recommend items that are similar to one to the similar that are similar to the one of the ones the user has already rated highly. Okay, understood. So there are going to be two collaborative filtering. First is user based and second is item based. The user base is, for example, there are two users A and B. A and B are similar users. Similar user how? Because their taste or their purchase or their history sounds similar. Then if user A picks something, user B is also going to like it. So we are going to recommend items based to a user based on the items that the similar user liked. Okay. Then the other type of collaborative filtering is item based. So, for example, I have picked jam. So there are high chance that jam. If I'm picking jam, I may also like honey, right? If I'm picking, let's say, almonds, then high chances that I may like any other dry fruit. Second is item based. So recommend items that are similar to the one that the user has already liked or already rated high. For this project, we are going with user item rating. It has already mentioned that we have to go with user item rating. So we will go with the first one. Okay. So the step for the problem is going to be to build approach to build a recommender system is first we will load the data. We'll use a data set like movie lens which has user ratings of for different movies or any other data set where users rate items. Okay, so we are going to use this data set. Then we are going to create a user item matrix. This is going to be an interesting problem. So we are going to build the user item matrix. We will convert the data into a matrix where rows represent users and column represent items. Okay, understood. The values will represent the rating of the user for that particular item. Now understood. Collaborative filtering approach, we will use cosine similarity or Pearson correlation to find the similarity between users or items and make recommendation based on those similarities. This is going to be interesting. I will understand two what these are actually. Then we will split the data into training and test sets. We will build the recommendation model. We will use a collaborative filtering algorithm to predict the ratings of the for the user items pairs that have not been rated yet. Okay. Evaluate the model. We will use root mean squared RMSE and mean squared metrics to evaluate the performance of the model. Okay. It says, would you like to proceed with a specific data set for this recommender system, such as movie lens data? Let me know. Yes, movie lens data set sounds good. Let's see what it is going to recommend. Okay, we are going to get the data again from Cabin. Then we will build the user data matrix, implement correlative filtering, make predictions based on similarity. Okay, understood. Today, if you see, it is giving me the solution in a different way, but good. So let's start with loading the movie lens data. So step by step is going to be, let's open the pie chart. Let's create a new file, Python file. It is going to be day10.py. Add it to the Git repository. Import files. It import pandas as pd. Again, it is going to help us easily manipulate and easily handle the data using data frames. Then what do we need? So yeah, let's go step by step. So we will use step number one is load the data. So we will load the data first. What we will do, we will go to this source. This is not linkable, so I'll simply go and Google it. Movie lens dataset, Kaggle, and 20 million datasets. Let's go ahead with this 100K datasets. 20 million is going to be a lot. So which one is it saying? Is it saying latest small movies and rating? Let's see what it will do. Okay, if I so this dataset describes 5-star rating and free text tagging activity from movie lens. Okay, a movie recommendation system. It contains thousand. Okay, 10 lakh ratings and 3,686 tag application score across 9,742 movies. Okay, and how it is going to look like? Okay, this is about the readme. Okay, let me download the dataset. Let's see what it will. Let's unzip it and go to this folder and ratings, movies, links, tags. Let's go back to the chat GPT. Here we will be using ratings and movies. So let's go and move this. So move, download, downloads, archive, and then we are going to have movies, dataset. Then we will do this with the ratings and move it here. Let's go what we see ratings and movies. We have got both things. Ratings and movies. Okay, understood. Now let's load the ratings and movies dataset. So ratings is going to be ratings is going to be panda dot read CSV dataset ratings dot CSV movies panda dot read CSV dataset movies dot CSV. Let's print it ratings dot head sorry head and print movies dot head and see what they look like. Python day 10 dot py. Okay, the ratings look like the user id, movie id, rating and timestamp. Then the movie looks like movie id. Okay, the movie id they look same, and the title of the movie and the genre of the movie. Okay, understood. And the same movie has been rated in this ratings data frame. Understood. Now let's go comment it. Okay. Uh, oh, nice. Let's write it. View the structure of the data set. We already saw it. So okay. So now let's go to the step number 2, which is this is what we are getting. This is create user item matrix. Create user item matrix. And here what we are doing, we will use okay. We will create a matrix where rows represent a user and column represent movies. Okay. And the values are ratings given by the users to the movies. Missing values indicate that the user has not rated the movie. So what we will do, and the so user item matrix. What we are doing, we are using ratings dot pivot. Index is user ID. Index is user ID. This is going to be the index, and then index as in the rows are going to be user ID. It has clearly told us that the rows are going to be here. The rows represents user, so the rows represents user. Column represents movies. We will use columns represents movie ID. Is it the same? Yes. And the value represents rating. So values is going to be rating. So pivot table we can create from the user item matrix we can create from the user. So from rating data frame itself. So the user ID will be the rows, for column the movie ID, and the values are going to be ratings. So let's print it, user item matrix, rerun it, and we see some error. Okay, this should be in the, and this is rating. See, it is rating. So clear it and rerun it. Oh, we do see some data, right? And we see that the value, if it is null, then it is not filled. The user has not rated that movie yet. For that, what we are going to do, we will fill the missing value with 0. So what we are doing, fill the missing value with 0 or none, if we prefer sparse matrix. We'll go with what ChatGPT suggests because I'm solving it for the first time. If I use this method, fill any, fill any as in the missing values, and we will fill with 0 and in place true, as in place. And let's print again user item matrix, clear it and run it. Whoa. We see the value the user has rated this. We see the value the user has rated this also, but for the other values it is 0 0. Is it in place? Yes. Hey, okay. And then I'm going to comment it. Then step number 3 is going to be what we are to implement collaborative filtering. Implement collaborative filtering, as in chances that the user A is going to like the other user, which item the user will like more on the basis of the other user, right? User based, sorry, item based collaborative filtering. Earlier it said user based, right? Okay, item based. So let's understand. We'll use cosine similarity to find similar users or items. Okay, we are using both users or items. For user-based collaborative filtering, we calculate the similarity between users, and for item-based filtering, we calculate the similarity between movies. Okay, let us use item-based collaborative filtering. Okay, so I'm going to have this here. So what I've understood here is that we will be using cosine fit similarity for finding the similar users and items. For user-based collaborative, we saw that there are two types of collaborative filtering. For user-based collaborative filtering, yeah. So user-based collaborative filtering, we calculate similarity between users. And for item based collaborative filtering, we will find the similarity between the movies. Here items are movies. Okay, for user based we will find the similarity between the users. For item based we will find similarity between the items, and here items are movies, so we will find similarity between the movies. Now we will go ahead with item based collaborative filtering. Why? Because that is, we recommend movies item based, as in we recommend. For example, a user A has liked a movie which is a comedy type movie, so we will recommend another movie of comedy genre. So we are going ahead with item based, which is movie based filtering, that we recommend movies similar to the those that the user has already liked. Understood? Example, uh, recommend a comedy movie because user has already liked a comedy movie. So it's an example, a rough example, right? So let's go and start. Cosine similarity. Let me understand what this cosine similarity is. Okay, let me ask this cosine similarity. Can you please explain in easy words? So now we've understood the collaborative filtering, but let's understand what this cosine similarity is, because we will be using it, right? If I see here, we will be using cosine similarity on our user item matrix that we had created. Transpose to get movie to movie similarity. Okay, it is generating. Okay, it is going to be long, but yeah. Okay, let's start understanding it. Cosine similarity is a measure of how similar two items are based on their values or features. The key idea is to treat each item, in our case user or movies, as a vector, a set of numbers. Okay, and then measure the angle between these vectors. Okay, if vectors point in same direction, the angle between them is small or 0 degree, they are considered similar. If the angle between them is large, which is 90 degree or more, they are considered dissimilar. Okay. Cosine similarity helps in finding how closely two vectors are aligned. Okay, so first, what it does, it each item, be it a user, be it movies, it converts those or as vectors, which is like a number, set of numbers. Now it plots those set of numbers and then it finds the angle between each movie. Now, if the angle between the two movies is going to be less than 0 degrees or small, then it going to be considered as similar. They are going to be considered as similar. If the angle between them is going to be large, which is 90 degree or more, they are considered dissimilar. Cosine similarity helps in finding how closely two vectors are aligned. regardless of their magnitude, which is how long the vectors are. How it works? In our case, we treat users or movies as vectors. For example, a user vector would represent all the ratings the user has given to the movie. A movie vector would represent how different users rated the movie. Okay. Example, let's take two movie vectors based on user ratings. Movie A is going to be 5031 ratings by user 4 users. Movie B has been rated by 4 users, same 4 users. The rating is 4031. Okay. Cosine of, so the user movie A has been rated by 4 users. The same 4 users rated the movie B like this. So we have a vector cosine of the angle. The cosine similarity formula measures the cosine of the angle between these vectors. So, okay, between the two vectors. If the angle is 0 degree, they point in the same direction. The cosine similarity is 1. They are very similar. If the angle is 90 degree, the cosine similarity is 0. If the angle is greater than 0, which is so they are not similar at all. If the angle is greater than 90 degree, the cosine similarity can be negative, can be even negative, which means they are very dissimilar. Okay, so we'll be going with this one. Formula is this. I don't want to go into the formula. Let's understand why it is useful in recommender system. Cosine similarity focuses on angle between the factors and ignores the magnitude. This means that even if one user rates everything higher, always like gives 5 star, it will focus on pattern similarities rather than the absolute rating. Okay, understood. So, for example, we have a rating from 0 to 10, 100. One user always one user is always rating like in higher numbers 90, 98, 95, 87. The other user is rating in like 5, 4, 7, 8. So it will not go on the magnitude, it will go on the pattern. It will go on the pattern similarity rather than the absolute ratings. If a user has rated some movies and you want to recommend similar movies, okay, you can calculate if a user has rated some movies and you want to recommend similar movies, you can calculate the cosine similarity between the movies the user has rated and other movies. Movies with higher cosine similarity will be more likely to be enjoyed by the user. Understood. So basically, cosine similarity tells us how similar two items are on their features. Hmm. It measures how close the two items, vectors, or are in terms of direction, that angle between them. Okay, understood. So what we have understood here is it goes, or the whole base is calculating the angle between the two items, and the items are going to be two vectors. This is vector 1, this is vector 2. I have already told you about this example. We have already understood, not told you. So if the angle is going to be small, they are going to be similar. If the angle is going to be large, they are not going to be similar. And why it works with the recommender system is cosine this cosine similarity is because it does not go on the magnitude. For example, again, if a user usually rates movies higher and the other user rates movies lower, so it will go on the pattern rather than the absolute uh, of, ratings. Okay, so why we will use cosine similarity to find we will use cosine similarity because it because it focuses it focuses on pattern similarity rather than the absolute rating. Okay, so let's go back to the code of our step number 3. For this, we will have to import the cosine similarity from sklearn matrix pairwise. So let's go back and import sklearn, uh, what that is, matrix pairwise, not this, from this import cosine cosine similarity. Okay, then cosine similarity we are going to use. Uh, we are going to do, we will do what? We will calculate cosine similarity between movies. Calculate cosine similarity between movies. We will be doing that. So item similarity, we will do cosine similarity between what? User item matrix dot transpose. Here, why are we doing transpose? Here, why are we doing transpose? So why it says that we need to transpose a matrix in this step. Uh, the user matrix item matrix is structured that the rows represent user, column represent movie, values represent the rating that the user has given to the movies. Correct. This is how our user item matrix is looking like. The matrix shows which movies are rated by which users and the ratings were given. Why transpose? When calculating item based similarity, we want to compare movies with each other, not users. Okay. Without transpose, the default structure of user item matrix has user on the rows and movies on the column. If you calculate similarity on the matrix without transposing, we will be calculating user to user similarity instead of movie to movie similarity. Okay. Okay. So this is a vector. This is a vector. This is a vector. Earlier, the vector was targeting a user base. Earlier, the this is a user base similarity, and this is going to be a item based similarity. Understood. 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 So we'll have to do transpose. Okay. Okay. Let me paste it. Okay. Uh, we did transpose because when calculating item base similarity, we want movie to movie, not users. Understood. Let's do that. We did. Now we understood why we did that. Now create a data frame of it. Dot. Let's go back to our code. Step number 3, data frame, and the value is going to be item similarity, and then the index here is user item matrix dot columns. Columns were, if you see, the columns were the movies, so we want the rows now to be the movies, and the columns are again going to be the same. Sorry. Oh yes, columns are going to be the same. Columns are going to be, so it has become a movie to movie. Let's print it. Item similarity data frame dot head. Let's rerun it. Clear first and then run it. We can see this movie is rated this is okay. The similarity of okay. So the similarity between use one and one is this. The similarity between one and two is this. But one and three is this. So the similarity of one movie number one with the other movies is represented here like this. I am curious to see what this item similarity looks like. Okay, for it is looking like this, an array. So we have to convert an array here. Okay, step number four is we are done with it. Make predictions based on similarity. Step number four is make predictions based on similarities. So today's problem is looking a little different if we see similarity. So we are creating this